In the previous session, we have seen how a Spring MVC application can be created using the wizard. One thing I forgot to mention is that if you look at the pom.xml file, you can see that the servlet API version that is specified is 2.5. Our aim is to develop a Spring MVC application using annotations only and eliminate the usage of XML. For that, we need a servlet API which is higher than 3. So this is what we are going to do now. But before we go into that, let us delete the elements already configured in the pom.xml file so that we can start anew. It will give you an idea of what are the dependencies that should be needed in a Spring MVC application. So the first thing that we are going to do is to get the servlet API. What I usually do, go to Google, type servlet API Maven. I will go with 3.0.1 as the servlet API version. So here you can see, copy it, come back to the pom.xml file. One thing you should understand, all these dependencies are added under the dependencies element. So inside that, just paste the copied servlet API. So now servlet API dependency is included. As you may be aware, this application, which was created by the wizard, is using JSP as the view technology. So we need the JSP dependencies too. So as usual, we go to the JSP, try to find out the JSP API. Specifically, I'm looking for 2.1. So here you can see there is a 2.1 JSP API. Copy it as usual and paste it. And the last thing that we are going to include is the JSTL. Why we are including JSTL? Because if you look at the source code inside the web apps, when webinf views, they are using a home.jsp page, and you can see there is a JSTL because there is a compiler error because JSTL jar file is not available. So we are going to look for a JSTL from the Maven repository. So JSTL, I will go with 1.2, that is the latest version. Copy it as usual, paste. So now we have completed configuring our application for servlets. So we have the servlet API with the version provided, the JSP and the JSTL tag. So once we have done the servlet API, we are going to add the Spring MVC dependencies. You can do the same procedure. I have already done that. I don't want to spend time on how to get the Spring MVC. So the only you need to understand, we need the Spring core library, then we have the Spring MVC library and the Spring Web MVC library. These are the three dependencies. I have already done that, so I am just pasting. I have already done that, and I'm just pasting the code here. So you can see I have copied the Spring core, the Spring Web and the Spring Web MVC libraries required for Spring MVC development, and the version I am using is 4.3.9. If you see, I have included a logging framework dependency too. You don't need to worry about logging and all. We will talk about logging frameworks, the different logging frameworks and all extensively when we come to the Spring Boot section of it. But for the time being, what are the dependencies that we have added? We have the servlet API, we have the JSP, of course we have the JSTL too. Apart from that, we have the Spring Core and the Spring Web MVC dependencies. The next thing that we are going to do, as again I am reiterating what we are trying to do, we are trying to create a Spring MVC application just by using annotations. So what we are going to do, we are going to delete all the existing XML files, starting with the deployment descriptor. So if you are with me, delete the web.xml file. Also there are bean definition files, two bean definitions files. If you remember, there is a root context and the servlet. We are not using any of these XML files, so we are going to delete the Spring folder itself. Okay. Now, because when we deleted the XML files, errors start creeping in to the pom.xml file. If you point your mouse, you can see there is a message appearing. Let me zoom in, that fail on missing web XML is set to true. So what we need to do is that we need to create a new properties section. Inside the properties section, we are going to give fail on missing web XML, and we give a value of false. Once the build is complete, the error goes away. Before we complete the configuration of the project, I can see there is another error. It shows, let me again zoom in, it shows that this particular dependency is missing. This is by experience how we come to know what are the different errors that can appear. So this means that this particular artifact is missing from the repository location. So what went wrong? Because we just copied it from this particular location, if you remember. So let us go back to the repository and see what went wrong. I will go back to Google, have the same procedure, servlet API, Maven. If you remember, we selected the version 3.0.1, and we copied this, if you remember. But then we failed to notice that there is a notification area in red telling that this artifact was moved to this particular location. What this effectively means is that if you look at the artifact ID here, it is servlet-API. So instead of that, we need to change it to javax.servlet-API. So the only thing you need to do is come back to Eclipse. Instead of the servlet-API, we give javax.servlet-API. That should be enough to solve our problem. Now you can see the errors have disappeared and we are good to go. That is the project dependency management aspect of Spring MVC. The next thing we are going to do is that we are going to start configuring the dispatcher servlet and the beans. Again, I am reiterating, we have deleted all the XML files from our project. But then, as you know, the web.xml is one of the main artifact for our project, but we have deleted the web.xml file and the bean definition files too. But there has to be some way of configuring these. So this is what we are going to do next. But before that, let us discuss some theory behind the scenes of what we are going to do next. Now let us look at the theory behind how we can configure a Spring MVC application using annotations. Spring MVC has provided us with an interface known as the Web Application Initializer. And what does this interface do? The implementation of this interface is detected and automatically used to initialize any servlet tree container. Please remember, this class is a replacement of the web.xml using Java code. So please understand that. I'm again reiterating, Spring MVC has provided this interface for us, and an implementation of this interface is automatically detected to initialize a servlet tree container. Here in the code you can see we are implementing this my web application initializer and overriding the onStartup method. And the signature of the startup method is the servlet context. Any servlet knowledge, servlet API knowledge is adequate to understand what a servlet context is. Inside the on startup method, we are creating an instance of the application context. This is a web application, so we are creating a web application context. As a refresher, what does an application context mean? It's wherever beans are managed, that's all. And once we create the instance of the application context, we are pointing that instance to a location where beans are defined. Again, we are not going to use any XML files, so when we implement the web application initializer, we need to have an XML file for bean definitions. Our ultimate aim is not to use any XML, but I am just going through the theory one after the other. So once we have assigned the bean definition file to the application context, the next thing in code, what the code is doing here is that we are creating a new dispatcher servlet instance and assigning that application context to it. So the theory behind Spring MVC is that each dispatcher servlet has a web application context associated with it. So this piece of code, what we are going to do, we are adding this dispatcher servlet onto the servlet context. This is equivalent to creating the dispatcher servlet in the web.xml file, and then we ask through code to boot up or create an instance of the dispatcher servlet on startup, and the mapping is also provided so that when a request comes with the root context, the dispatcher servlet will take it up and process it. So instead of implementing the web application initializer ourselves, Spring Guys has given us an abstract implementation of the same, known as the abstract dispatcher servlet initializer. This abstract class makes it even easier to register dispatcher servlet by simply overriding the methods to specify the servlet mapping and the location of the dispatcher servlet. So here you can see there are three methods, and in the create servlet application context. So again, I am reiterating, in the previous slide we were implementing the interface directly. So Spring MVC has given us an option, or has implemented that interface known as the abstract dispatcher servlet initializer. So instead of we implementing the interface ourselves, we just extend from the abstract dispatcher servlet initializer and override the methods. And here we are overriding the create servlet application context, where we are creating the application with the web application context and pointing it to the bean definition file. And in the get servlet mappings method, we are providing the URL. So again, I am reiterating, instead of implementing the web application initializer, you can extend from the abstract dispatcher servlet initializer. But this piece of code is still using an XML for bean definitions. But as we have been saying from the start, we are not going to use any XML files. So finally, we have reached where we can have a Java-based Spring configuration. So here, another abstract implementation called the abstract annotation config dispatcher servlet initializer is extended. If you go back one slide, here it was the abstract dispatcher servlet initializer. So if you still are happy with having bean definitions in an XML file, you will be extending the abstract dispatcher servlet initializer. But the aim of this session is to get rid of all the XML files. So then, if that is the case, we will extend from abstract annotation config dispatcher servlet initializer. And we have three methods overridden: get root config classes, get servlet config classes, and get servlet mappings. So in the get servlet config classes method, we are passing in another Java class. The name given is web config. So This class named the webconfig is a replacement for the bean definition XML files. Again, I am reiterating, from the start we have been telling that we are trying to eliminate usage of web.xml file. So this particular class, my web application initializer, is a replacement of the deployment descriptor, which is the web.xml file. Okay, and we initially started with an interface, then we came to another implementation of the interface given by Spring MVC, and there also we were using the XML for bean definitions. And the last thing that we saw, instead of extending from the abstract dispatcher servlet initializer, we are extending from the abstract annotation config dispatcher servlet initializer. So what I was explaining just now, so in the getServletConfig classes method, we are passing in another class known as webconfig.class. This class is a replacement for the bean definition XML files. So what that means is that we are going to define the beans used in this application in this particular class. Another method is the getRootConfig classes. If you remember the code that was generated by the wizard in the web.xml file, there were two bean definition files. One was called the root context, and the next two was the application context used by the dispatcher servlet. So if you have a root context, meaning if you have any beans that is common to other application context in the application, you will define those beans here in the getRootConfig classes. For example, if you have a security implemented, or transaction, or caching, these beans are applicable across all the other application context of your application. You will put those beans in a root context. But as of now, we don't have any bean definition in the root context, so we are just returning it null. And the last is the getServlet mappings, where we specify the mapping to the dispatcher servlet. I hope the theory is understood a little. Now let us go to how we are going to replace the bean definition files itself. So the theory till now, what we have discussed, this particular class, my web application initializer, which is extending from the abstract annotation config dispatcher servlet initializer, is a replacement of the web.xml file. And the next thing we are going to do is that how we are going to replace the XML file. So here you can see no XML files, we only have a Java class. So this webconfig.class will be the replacement for our bean definition XML files. So let us look at how we are going to code that. So to enable MVC Java configuration, add the annotation at enable webMVC in one of your configuration classes. So the one thing you should remember, if you see this @configuration annotation in any of the Java classes, it means that it is a replacement. This particular Java class named webconfig is a replacement of the bean definition XML files. This means that this Java class contains bean definitions. Okay, I am reiterating, this particular class, public class webconfig, with an annotation at configuration, with annotation at enable webMVC, is all that is required for your MVC application to work. Okay, and this at configuration annotation is an important annotation. This means that this particular class contains bean definitions. Again, this piece of code does a lot of things behind the scenes. For example, this particular piece of code at configuration at enable webMVC inside this webconfig is equivalent to this particular piece of XML code which we are used to do before. Okay, the same configuration. So if you are not going to use Java classes, but instead you will be using XML for bean definitions, this will be the signature, at least the basic signature of the bean definition file. So this Java configuration is equivalent to this particular XML file. I hope you are getting me. But this piece of code, does a lot of things behind the scenes for us. Now it is not the time to go deep into this, but what it enables for us is important. So I will give a brief about what happens behind the scenes, or what Spring MVC does for us behind the scenes because of this particular class and because of these annotations. So the code that we just saw enables the following. It registers the request mapping handler adapter, exception handler, exception resolver, and apart from that, it also enables conversion service, support for formatting, HTTP message converters, and such. So what does this mean to us programmers is that without we writing a single piece of code, a lot of functionality is available out of the box. For example, mapping a URL to the corresponding controller handler method, or converting object to XML or JSON and back. All these things are handled for us by Spring MVC. Again, I am reiterating, by just writing this piece of code at configuration at enable web MVC into a Java class. This enables us to have all these default functionality available to us. Okay, but of course there are always, and here is the complete list of the HTTP message converters supported out of the box. Byte array, mostly we will be concerned about mapping Jackson to HTTP message converter, because we are going to talk extensively on REST APIs, where we will be using mapping Jackson to message converter to convert an object to JSON and from JSON to object. That's what this particular converter is going to do. Okay, but there always comes a time, okay, we are okay with the defaults for a start, but we cannot complete a project with the defaults. We will always have to customize this configuration. So what should we do? What we are going to do, we can implement the WebMVC configurer interface. So here either you implement the WebMVC configurer, which is an interface, or more likely extend the WebMVC configurer adapter and override the methods. I'm again reiterating, whatever the class we are writing, the web config, remember the name. If you go back to the to one of the slides, yeah, so I am talking about this web MVC. Here we are not implementing or extending from any other classes. Okay, just a standalone class with 2 annotations given. This is the default configuration you need to get up and rolling. But if there is a need for you to customize it further, for example, we are not happy with these default configurations, we may have to override. Maybe we have our own mapping Jackson to, or our own message converters. Okay, so we need to add that bean. So what we have to do, we will extend our web config from either the WebMVC configurer, which is an interface, so we have to implement the interface and implement the methods in the interface, or what we do is that Spring MVC has already given us the WebMVC configurer adapter, which we extend and override the methods that is required. There are n number of methods out there for this particular WebMVC. We will go through that when we discuss through code, but here 2 methods are overridden. One is add formatters and configure message converters. So as an explanation, suppose you have your own converter, then you will register that converter by overriding the configure message converters. Apart from this, we can define our own beans here. If you remember, I already told you, whenever you see at configuration annotation in any of the Java classes, this means that this particular Java class can contain or will contain Java beans or Spring Bean definitions into that. Now that is all the theory part of it. Let us do some coding based on this.